Yeah. So here, if you look at this slide, yeah, right. So here, hmm. So yesterday I told about position vector, and we are talking about the three-dimensional space there, and so right. So we have position vector. We talked about position vector. Here the in this PPT I am giving this position instead of ijk. We are see instead of ijk, because this I am uploading this document in the Google Classroom, this PPT. That's why I am telling you. So here r bar is he is writing like this. So sometimes we write like this, and sometimes we also write like this. See, I bar is the unit vector along the x-axis, x direction. The j bar is the unit vector along y direction, and the z bar is and k bar is the unit vector along z direction. So sometimes they are writing ex. See here, like we have here, right? So ex, ey, ez. That is ex plus y subscript plus z ez. They may write like this. So what I mean to say is that, see, these two things are one and same. K bar and ez is same. Z bar ey is same. I bar ex is same. So that is about right. So and then we have this f bar. See, yesterday I told vector valued function. So when we are talking about vector valued function, we write f bar, and in this case we told it can be written like this. So j bar component, j bar like, or sometimes we may write instead of in this presentation I told, in place of p, if f1 we are writing I bar plus f2. In place of f2 we are taking j bar, and in place of f3 we are taking that. They are one and same. That's what I would like to convey. So this gradient definition we have given, phi x, phi y, phi z. Gradient mean dou phi by dou x. I mean I bar plus dou phi by dou y, j bar plus dou phi by dou z, k bar. That's what we told. And gradient operator means sometimes we can write like this also. This is for convenience sake. What I'm while doing problems, it becomes easy for us. So right, this notation already I explained. And the gradient field, see, f bar is a gradient field, then there exists phi such that f bar is equal to grad phi. So it is called a conservative field. We people call it f bar is conservative field. F bar is conservative. A vector field uh, is conservative vector field. So when if there exists a potential phi, I mean scalar function phi, such that if there exists a potential phi such that if there exists phi such that a grad phi is equal to f bar. Grad phi is equal to f bar. Okay. So now, right, this is called conservative vector field, that we will check, and then see curl of f bar. Already yesterday I have given the explanation. Divergence of f bar in terms of PQR he is writing, that's all. And these actually the 7 and 8 are important here. F bar is equal to grad phi, that is what I told. Then curl f bar is 0. F bar is grad phi, then curl f bar is 0. That is very, very important thing. So see here. These are very important things. See, if you say there is a phi such that f bar is equal to grad phi, then it is called a conservative vector field. It is called a conservative vector field. I mean conservative vector field. F bar is conservative, we can say. And phi is called potential. And see, this is nothing but curl f bar is equal to 0. So in that case, f bar is irrotational. F bar is irrotational. This is very important. They will frequently ask this question. There is a possibility. So F bar is irrotational. Just simply to show that F bar is irrotational, simply show that curl F bar is equal to 0. If you want to show F bar is conservative also, simply show curl F bar is 0. That's enough. Okay. So that is one important thing. Right. You'll go to problems, then better you'll face those things. Okay. Right. So this 7 and 8 points are important. See, these are a few important I mean laws. Among them, see, the double application laws are important. That is, divergence of curl f bar is 0. See, there is a high possibility that these things they will ask in multiple choice questions. See, this one, divergence of, that is del dot means divergence of, del cross means curl f bar is 0 always. Similarly, curl of grad phi. See, this is called grad phi. Grad phi. Curl of grad phi is also 0. And then that's all. These two again, 10 and 11, they are very, very important ones. And above all, one more thing is that, okay, okay. Now see, here, that is what I wrote, dive curl bar. See, here I wrote divergence of curl f bar. So 10 and 11 are important. 10 and 11, you can note these things. Del dot del cross f bar is 0. That is also known as divergence of curl f bar is 0. That is very important thing. Then curl of grad phi is 0. See, the curl of grad phi means del cross del phi is equal to 0. These are the two things. In addition to these two things, we require see, grad f bar is equal to grad phi is equivalent to curl f bar is equal to 0. F bar is equal to curl g bar means div f bar is 0. These two things are 7 and 8 are important. 7 and C, phi is scalar potential. That is what I told you. F bar is conservative vector field, and that's all. That is very important. Okay. So, right. And in addition to that, yeah, we already discussed about these line integrals. We'll do some more problems on this. Then I'll come to, yeah, yesterday I talked about Green's formula, Green's theorem. That also we will do some more problems. Okay, now we'll see to the problem solving part. So if I go to problem solving part, just a minute, it was struck. Right. So we are doing some problems here. And this is, what is this one? No, no, changing order is not the thing we want. We want Green's theorem, multiple integrals. We are looking at some other thing. What is that? Just a minute. Somewhere else I missed this. Multiple integrals. Hmm, yesterday I have given some. Yeah, right. I think this is the one. Yes. Okay. Hmm. Today it was small. Where is this? No, not this one. Yesterday we have done some problems. Calculus, different multiple integrals I have already done. Ah, yes, this is. Yes, right. The divergence of a vector field is. This I think yesterday we have done. Gauss divergence theorem. Yeah, it relates to surface integrals to volume integrals. That is wrong. Surface integrals to yeah, surface integrals to volume integrals is the correct one. Gauss divergence theorem. Here, divergence theorem. Gauss divergence theorem. Okay, I'll write fresh. Better I cancel this. This word is not working. Yeah, it's right. Okay. Right. So yesterday I told you there is something called Gauss divergence theorem. Gauss theorem in short I will tell. This relates surface integrals to volume integrals. Surface integrals to volume integrals. And Stokes theorem talks about uh, Stokes theorem talks about surface integrals to, this is enough, integrals to line integrals. Okay, so now we look at that question, right? So for 6, A is the answer. 7, given a vector field F bar, the divergence theorem states that F bar dot ds bar is delta divergence of F bar dv, that is one thing. Then F bar ds bar is equal to del cross F bar, that is wrong. C is also wrong. D is also, wherever, see here divergence is there. So the answer is here. Okay, the answer is surface integral to, where is that? The surface integral to divergence theorem means surface integrals to this is divergence of F bar dv, that is A is the correct answer. Then we go to 8th question. This is 7th question. 8th question. The vector field F bar is diverge. This also we have done, I think. 8th question we have done. This we have done. Value of this one. This, yeah, this we will see. value of xy dy. Okay, value of xy dy by square dx. Value of, okay, you have xy dy. Okay, value of xy dy minus y square dx. Minus y square dx. This value we want. This also I think yesterday we have done. Uh, by using Green's theorem, yes, we have done this. Stokes theorem, line integral to surface integral, that is 11a is the answer. Uh, okay, the line integral v bar dot dr bar of the vector field from the origin to the point P1 is, okay, this we will do. Line into v bar dot dr bar. V bar dot dr bar. Line integral we are talking about. So this line means a curve. This needs to be found. What he has given? V bar is 2xyz I bar. V bar is 2xyz I bar. V bar is 2xyz I bar plus x square z j bar. X square z j bar plus x square y k bar. X square y k bar. And R bar is always, I told you, x bar, sorry, R bar is xi bar plus yj bar plus zk bar. So then dr bar is always remember I bar dx, j bar dy. Just you are prefixing d to xyz respectively. So k bar into dz. Now we are making dot product of vr bar dot dr bar. So corresponding coefficients we will add. Dot product means. So 2xyz I bar quotient into dx plus j bar quotient. What is j bar quotient? X square z. X square z is the j bar quotient. X square z dy plus x square y dz. X square y dz. So what we have done here? We have 2xyz into dx, that is 2xy dx, yz dx, x square z into dy, x square z into dy is there here, and x square y into dz, x square y into dz is there. So that is v bar dot dr bar. This is v bar dot dr bar. And now v bar dot dr bar we found as 2xyz dx plus x square z dy plus x square y dz. What else is given here? From origin to 111. From origin to 111. So line from origin to 111. So that is line joining, line joining 0, 0, 0 to 111. Okay. Line joining 0, 0, 0 to 111 is given by, line joining 0, 0, 0 to 11 is given by x minus, see, one point we are fixing 0. We have a formula, x minus x1 by x2 minus x1 is equal to y minus y1 by y2 minus y1 is equal to z minus z2, z minus z1 by z2 minus z1. So 1 minus 0. How I am getting this 1 minus 0? This 1 minus 0, I am getting, see, this 1 minus 0. Okay, is equal to y minus 0 by, we are fixing origin, 1 minus 0. How I am getting this 1 minus 0? This 1 minus 0 is 1 minus 0. Okay, then is equal to z minus 0 by 1 minus 0. So this implies x is equal to y is equal to z. So this is the curve, what we call line integral. This is the curve. So if we say x is equal to y is equal to z, immediately you can say dx is equal to dy is equal to dz. So very important thing is, here two things are there about this line. One is x is equal to y is equal to z. The other is dx is equal to dy is equal to dz. So now we go to this integration part. V bar dot dr bar along the line. Where is that line? That line is this. That line is this. This is the line joining. We are saying line joining, line segment joining. That we are denoting by C. So now this is what we have. We are asked to evaluate V bar dot dr bar. This is equal to integral. Just simply I am substituting V bar dot dr bar here. 2xyz dx 2xyz dx 2xyz dx plus x square z dy plus x square z dy, okay, plus x square y dz plus x square y dz plus x square y dz. So now see, what we are doing is that we try to, because this integrand involves all the variables x, y, z, we want to convert this into a function involving only integrand involving only one variable. Yesterday we have seen, the previous class we were told that
Sir,
a line in, yeah,
sir, why
yeah,
did
tell
you
me.
like make here x equal to y equal to z, sir? If you have the formula v into dr, why did you do that?
Because see, this is basically a line integral first. Okay, so you are integrating this vr bar dr bar. We are integrating, just a minute, we are integrating, yeah, we are integrating this vr bar dot dr bar along this line C. How this C is described? This C is described by a line connecting 0, 0, 0 to 1, 1, 1. And we know that line equation of line connecting x1, y1, z1, x2, y2, z2 is x minus x1 by x minus x1 by x2 minus x1. Sorry, so what is happening here? Uh, uh, x2 minus x1 is equal to y minus y1 by y2 minus y1 is equal to z. This is a formula actually. Z2 minus z1. So this is formula here. Now if I put that formula, if in this formula, if I put 0, 0, 0 in place of x1, y1, z1 and 1, 1, 1 in place of x2, y2, z2, then I am coming, we are getting x is equal to y is equal to z as the equation of the line. Now then why we are putting this one there? Because this being a line integral, v bar dot dr bar is a line integral. You can solve this line integral by reducing this into a single integral. Yesterday I told that one clearly. You can solve this one by reducing this into a single integral, or by reducing this into a double integral, or by reducing this into a double integral. Double integral means it should be a closed circle. I mean closed curve. This is not a closed curve. So there is no option for us to reduce this into double integral. So the only option is you have to reduce the integrand, this integral, line integral, into a single integral. Single integral means integrand should involve only one variable. It is up to you. You can choose only in terms of x, or in terms of y, or in terms of z. That is the reason. So we are now, that is why using on the line joining 0, 0, 0 and 1, 1, 1, the relationship is x is between x, y, z is x is equal to y is equal to z. And so dx is equal to dy is equal to dz. So that is the reason here why we are doing like that. So simply I put this here, we put that x is equal to y is equal to z here. So if we get that, xyz means x cube. So 2x cube dx plus x square z. Everything we want to write in terms of x. So z is also x. So x cube dy is dx. So I am writing dx plus again x square into y. So y is z. So x cube again dz is dx. Now we got, see, we got the whole integral, line integral is got reduced into a single integral. Single integral means integrand has only one variable, that is x. So now this is 2x cube, 3x cube, 4x cube. So what we get, what we will get here is that is equal to integral 4x cube dx, x is equal to 0 to 1, because your line, along the line x varies from 0 to 1, y varies from 0 to 1, and z varies from 0 to 1. So only the integrand involves only one variable x, that varies from 0 to 1. So you have x power 4 between 0 1. So you are getting the answer as 1. So A is the answer here. 12. For 12, A is the answer. We do similar problem, then you can understand. Actually, we have to choose like that. Okay, I'll choose one more problem like that. This is a standard one. So u is equal to x square by 2 plus y square by 3. U is equal to x square by 2 plus y square by 3. U is equal to x square by 2 plus y square by 3. The magnitude of the gradient at 0 point at 1 comma 3 is. So he is asking for grad u, grad u at grad u at, okay, he is asking for grad u at xy is equal to 1 comma 3. Xy is equal to 1 comma 3. So that is at xy is equal to 1 comma 3. So then see what is happening here. What is grad u? Grad u formula, grad u is dou u dou x I bar plus dou u dou y j bar plus dou u dou z k bar. So what is our dou u dou x? Dou u dou x is 2x by 2, so x, that is. So x I bar plus What is dou u dou y? Dou u dou y. 2 by 3 y. 2 y square is 2y. 2 by 3 y. So we have 2 by 3 y j bar. What is dou u dou z? Z is not there here. So it is 0. So 0 k bar. So this is what we are getting is xi bar plus 2 by 3 y 2 by 3 yj bar. Now what he is asking? Is asking for grad u at xy is equal to 1 3. So right now, therefore, grad u, I write like this also, at xy is equal to 1 3. So in place of x you put 1, in place of y you put 3. Okay. So if that is the case, then in place of x I am putting 1, 1 into I bar plus 2 by 3 into j, y is actually 3 there, 3 into j bar, anyway that k bar component is 0. So what we got here, I bar plus 2j bar. So if you ask modulus, see, always remember one thing. If you have something like r bar is equal to xi bar plus yj bar plus zk bar, modulus of r bar is x square plus y square plus z square square root. This is the modulus. Okay. So this is a formula actually. This is a formula. If your r bar is xi bar plus yj bar plus zk bar, then modulus of r bar, that is called magnitude of r bar, is square root of x square plus y square plus z square. So this is equal to, in this case, your I bar component is 1, so 1 square, j bar component is 2, so plus 2 square, k bar component is 0, 0 square whole. So you got square root of 1 plus 4, this is root 5. So magnitude is root 5. Magnitude is root 5. Magnitude also can be written like this. See, at, but please remember, this is at xy is equal to 1 3. That you are getting as root 5. So let me check whether that option is there. Root 5 is there. It is C. C is the option. Okay, we look at the computational ones. All right. You see this. Divergence of the field. Here we are asked to calculate the divergence of the field. So we write the field now. We write the field now. Here he is using the field by V symbol. Here he is using the field symbol by V symbol. So I simply write, okay. I simply write V bar is equal to, I simply write V bar is equal to minus x cos xy plus y, x cos xy plus y, x cos xy plus y minus I bar. Okay. Plus y cos xy j bar. Y cos xy j bar. Plus sin z square plus x square plus y square. Sin z square plus x square plus y square. Sin z square plus x square plus y square into k bar. This is our v bar. That this is our vector field. This is our vector field. Okay, right. Now we want to calculate divergence. Write the divergence formula. What is the so in short, you can treat this whole thing. You can treat this whole thing as P. You can treat this whole thing as Q. You can treat this whole thing as R. Okay. So how to apply the formula? So we have V bar is equal to Pi bar plus Qj bar plus Rk bar. Then I am writing divergence of V bar. Symbolically, this can be also be written as V bar. Formula is dou P by dou x. In short, we are writing P subscript x plus dot product is a scalar Qy, dou Q by dou y plus dou R by dou z. That's all. So what is dou P by dou x? Here minus x cos xy plus y. So P is minus cos xy plus minus cos xy plus y. Therefore, Px is cos xy. So treat y as constant. So for cos derivative is minus sine. So minus y sine xy plus again you have y there here. It is we are doing with respect to x. So it is 0. So Px is y sine xy. Px is y sine xy. Now look at the q value. Now look at the q value. Q is y cos xy. Y cos xy. So qy is, now see we have to use product rule. Y into, with respect to y we are doing. So minus x sine xy cos xy derivative with respect to y. Y quotient is x, so minus x is there, and cos derivative is minus sine, so minus sine xy. Okay, here please remember, when I am doing this one, I am treating this whole object as xy, x into y, sine of x into y. That is what I am thinking. I am not, see, sine of x into y is different from sine x multiplied by y. So I am treating like this, and so okay. So here also the same story in the above. In the above also, see, I am treating this as one object. That is why I am able to write like that. Otherwise, I cannot write like that. So this, okay. So right, y into that plus again chain rule cos xy. Because with respect to y also I have to do uv rule. uv derivative of uv is u into dv plus v into du. So if we do like this, then what we are getting here upon simplification, we are getting this as q, we are getting qy as minus xy sin xy plus cos xy plus cos xy. So this is qy. Now we want rz. Rz. What is our r? Before going for that, we need to know what is r. R is sin z square plus x square plus y square. R is sin z square plus x square plus y square. So now I want rz. Rz is clearly sine derivative is cos, so cos z square, and z square derivative is 2z. Of course, x square and y square are free from z, therefore their derivatives with respect to z is 0. Now we have to add these three things. What are the three things? Rx, Ry, Rz. I mean the Px, Qy, Px, Qy, and Rz. See, that is why we call divergence of V bar is Px plus Qy plus Rz. So divergence of V bar is Px plus Qy plus Rz. So this is equal to Px, just now we have written, it is y sin xy, y sin xy plus Qy means Qy is uh, yeah, minus xy sin xy minus xy sin xy minus xy sin xy plus cos xy plus cos xy. So this is and rz. Rz is 2z cos z square. That's all. So this will be the answer. Why he is again sin z square? 2z cos z square is there. B, none is the answer, I think, for this, because here what we got, 2z cos z square is there, cos xy and sin xy are also there. None of this is the answer. So 17, we'll check 17. If we check 17, 17 must be D. Yeah, he is telling. Oh, there is something. 17. 17. 17 is A. 2z cos z square only will come, he says. Have you checked this one, please? Have you taken this? Please, can you check once? V bar is minus x cos xy plus y, I bar, plus y into cos xy j bar, plus sin z square plus x square plus y square. If I ask for with respect to x, you have x sin xy is there. Find x sin xy is there. So where is that p value here? P is that. So, x cos xy. What p is? I didn't write x cos xy plus y. That is the problem here. Here x is there. So x cos xy means you have to, small correction. So you may have here x will come. Okay. Then cos xy also will come. Plus what is this? Cos xy into x. Cos xy into x will come. So you have minus cos xy. minus cos xy will come. So here plus xy sin xy plus xy sin xy, right, minus cos xy. That is the one. Minus cos xy will come. So then here qy means cos xy. Yeah, right. They are getting cancelled. See here. Yeah, right. Q px plus qy. Px plus qy. Please, I will take. See, if you take px plus qy, this x sin xy is there. This is minus sin x minus xy sin xy. That they get cancelled. This is minus cos xy, and this is plus cos xy. So px plus qy becomes 0. Px plus qy becomes 0, and so and then r is left. Rz is left as 2z plus cos z square. Okay. So here what is happening is that here xy is there, minus cos xy is there. So right, then this results in 2z cos z, 2z cos z square. So that is the A is the answer, right? What he said is right. See, look at here. I'll show this work. We started from here, V bar. We calculate divergence of V bar formula is there. Now P is the I bar quotient, Q is the J bar quotient, and R is the K bar quotient. So divergence of V bar is coming as this. Okay, 2z cos z square. Right. We go for another problem. We go for another problem. Yeah, right. The divergence of x minus y I bar plus y minus x j bar plus x plus y plus z k bar is, that is the next one. Okay. Next problem is find divergence of x minus y I bar plus y minus z j bar y minus x, not z, y minus x j bar plus y minus x j bar plus x plus y plus z k bar. X plus y plus z into k bar. So we want the divergence of this whole vector field. Okay. So for simplicity sake, we call v bar is equal to, okay, x minus y I bar plus y minus x j bar okay plus x plus y plus z k bar plus x plus y plus z k bar. So if you take this, okay, now see, we consider as before, we represent this by p, this by q, and this by r, and this by r. Now, what is divergence of pi bar? So that is, we have divergence of v bar. This divergence of v bar is px plus qy plus rz. Px plus qy plus rz. So, what is px? Px is 1 here. Dou p by dou x, x minus y here. So, dou p by dou x is 1 here. 1 plus, what is qy? Qy is dou q by dou y is again 1. So, it is again 1. And what is dou r by dou z? Dou r by dou z is again 1. So, plus 1, we are getting 3. So, we are getting the 3 as the answer. We'll check once. So, 3 is there for 21. For what is this number? Yeah, for 20, the answer is D. For 20, the answer is D. So, for 20, the answer is D. Yeah, so for 20, the answer is D. Right? For 20, the answer is D. Now, come over to the divergence of a vector field 3xz I bar plus 2xy j bar plus yz square k bar at the point 1, 1, 1 is equal to. Okay, so here again similar problem. So what is our v bar? V bar is 3xz I bar. So here v bar is 3xz I bar, 3xz I bar, uh, plus 2xy j bar, 2xy j bar, minus yz square k bar, minus yz square k bar. So, we have divergence of v bar is, therefore divergence of v bar is, so as before, we take this as p, we take this as q, and we take this whole thing as r. So what is px here? Px is 3z. What is qi? Qi is 2x. What is rz? Rz is minus 2iz. Minus 2iz. So we have divergence of v bar. We have divergence of v bar is equal to px plus qi plus rz. This is the formula. So we have this is equal to 3z plus 2x plus minus 2iz. That is the formula. Okay. So, we are asked to find divergence, at 1, 1, 1. At divergence at 1, 1, 1. So now the divergence at 1, 1, 1. Now the divergence at 1, 1, 1. So the divergence at 1, 1, 1. So x is 1, y is 1, z is 1. So 3 into 1 plus 2 into 1 minus 2 into 1 into 1 is. So 3 plus 2 is 5 minus 2 is 3 here. That's all. So divergence of V bar is 3 here. Right? Alright. That is the one. Then next problem. It's okay. It's what it is. It is 3. So if we want verification, it is 3. So 22. 22 is 3. You can verify it. 22 is 3. B. Right. 22 is B. 22. You're getting 4. 2 plus 3 plus 2 is 5 minus 2. Because PZ, what is PZ value here? RZ value is, RZ is dou Z is minus 2y. So right, what we got is right, it is 3 is the answer. Right. We go for the next problem. For a scalar function, fxyz is equal to x square plus 3y square plus 2z square. For a scalar function, f of xyz is equal to x square plus 3y square plus 2z square. The gradient at the point. So f of xyz is, f of xyz is x square plus 3y square plus 3y square plus 2z square. Now you want gradient of f, grad f. So that is fx I bar plus fy j bar plus fz k bar. So what is fx? Fx is 2x. 2x I bar plus iy fy. So 6y j bar plus fz 4z k bar. Fz k bar. So yeah. So what did they ask for? Grade at p is equal to 1 2 minus 1. P is equal to 1 2 minus 1 2 minus 1. So grad f at 1 2 minus 1. That is 2 into 1 into I bar plus 6 into 2 into j bar plus 4 into minus 1 into k bar. So this is equal to 2I bar plus 12j bar minus 4k bar minus 4k bar. Ja, that is B. 2I bar plus 12j bar minus 4k bar. That is B. B is the correct answer here. right? Now, the scalar function f of xyz is equal to x square plus 3y square plus 2z square, or then they are talking about the directional derivative, okay, right? Now come over to here. The line integral of the vector function, the line integral of the vector function along the x-axis from x is equal to 1 to x is equal to 2, right? So the line integral of the vector function will take this, the line integral of the vector function. What is we are discussing about? The line integral of vector function. The line integral of vector function. What is that vector function? F bar is equal to 2xi bar plus x square j bar. 2xi bar plus x square j bar. 2xi bar plus x square j bar. Right. Now along the x-axis from x is equal to 1 to x is equal to 2. So, yeah, right. What we mean by line integral? X is equal to 1 to x is equal to 2. Right, okay. So, here line integral means integral of f bar dot dr bar, that is the line integral. So, whenever we are talking about line integral, you take r bar as here because only I and j, okay, xi bar plus yj bar plus zk bar. So, what is dr bar? Dr bar, as said before, dxi bar plus dyj bar plus dzk bar plus dzk bar. So, we have f bar dot dr bar we want. So, therefore, f bar dot dr bar is equal to f bar dot dr bar is equal to, okay, 2x dx, 2x dx, okay. Then there the j bar comes x square, quotient of j bar is x square, so plus x square dy, and k bar component is anyway 0 in f bar, so x 0 into dz is 0. So fine, this is the one, but we are talking about x varies from 0 to 1. See here, we are talking about x varies from 1 to 2. So when x is varying from 1 to 2 here, that is the curve I am talking about. Line integral means curve. See here, line integral means curve. We need to evaluate f bar dot dr bar along the curve. What is that curve? That is the question here. So this curve is 1 less than or equal to x less than or equal to 2. So 1 is varying from x is varying from 1 to 2 along x-axis. Along the x-axis equation is y is equal to 0. So if we take this one, what we will get is that we can reduce that our c, along our c, 1 is less than or equal to x less than or equal to 2 is true. Y is 0 is true because we are moving along x-axis. Because y is 0, dy is 0. That is important. Dy is 0. So along the curve, this is what is happening. So if I say now, if we calculate what is f bar dot dr bar, f bar dot dr bar along C, this f bar dot dr bar is, 2x dx plus x square dy, 2x dx plus x square dy. What is x here? X is varying from 1 to 2. So in fact, we want to make this one a single, convert this whole thing into a single integral by taking x is equal to 0 to x is equal to 1. Okay. So simply dy is 0. That is what we know. So because dy is 0, this can directly be written as x is equal to 0 to, sorry, x is equal to 1 to x is equal to 2. Remember 1 here, x is 1, 1 to 2. Okay, 1 to 2. So 1 to 2 to x dx. So this is x square, x is equal to 1, x is equal to 2. So we have 4 minus 1, it is 3. 4 minus 1, it is 3. So 3 is the answer there. C is the answer there. Okay. I will take, so the direction of the vector a bar is radially outward from origin, and modulus of a is kr power n, where r square is x square plus y square plus z square and k is a constant. The value of n for which del dot a bar is 0. Okay, we will find del dot a bar first and then equate to 0 and find the value of n. Fine, that we'll see. So here, okay, because a bar is radially outward from the origin and modulus of a bar is kr power n, modulus of a bar is kr power n. So what we need to do? Okay, good, right. We'll do this problem. This is a good problem. So your a bar is, your a bar is, okay, no, right, is radially outward from the origin. So it is r bar, correct. But modulus of a bar is okay. Right, good. So, okay, we have to do like this. Radially outward means you have r bar, that is xi bar plus yj bar plus zk bar. Now, what is modulus of r bar? This also will write. It is x square plus y square plus z square whole power half, square root that is. We write this as r. We represent this as r. Therefore, what is r square? R square is x square plus y square plus z square. Okay. Now, for the sake of future work in this problem, I want 2r dou r dou x. Both sides we are differentiating with respect to, so it is 2x. Therefore, dou r dou x is x by r. Similarly, one can easily see that dou r by dou y is y by r, dou r by dou z is z by r. So x by r, y by r, z by r, they are dou r by dou x, dou r by dou y, dou r by dou z. Now, right, now we look at a bar. What is actually a bar? A bar is nothing but it is in the direction of r bar, he says. So we can write modulus of a bar into unit vector along r bar. So r bar by modulus of r bar. That is the thing. Okay. Again, we'll just look at the problem. So a bar is k. Modulus of a is k r power n. Yeah, good. A modulus of a bar is k r power n. So this is nothing but k r power n r bar by modulus of r. But we know that modulus of r bar, so you have k r power n here, r bar by, okay, modulus of r bar is, see already here we have, it is r. Modulus of r bar is r. We are representing by r. So I can simply write r here. So this results in k r power n minus 1 into r bar. K r power n minus 1 into r bar. So we need to calculate what is divergence of A first. Okay. No, the divergence of A. So yeah, right. See, so I can rewrite this as k r power n minus 1 into I xi bar, because r bar is okay. I will write xi bar plus yj bar plus zk bar. All right. So this is equal to k r power n minus 1 into xi bar plus k r power n minus 1 into yj bar plus k r power n minus 1 into zk bar into zk bar. Okay. Now see. So this is our. I can say this I represent by. Okay. This I represent by a1. This I represent by a1. This I represent by a2. This I represent by a3. Or we do like this. Y a1 a2 a3. PQR. This is P. This is Q. This is R. So our A bar is P I bar plus Q J bar plus R K bar. R K bar. Now we want divergence of A bar. So for that, divergence of A bar is Px plus Qi plus Rz. Px plus Qi plus Rz. So this Px plus Qi plus Rz in turn is equal to, so we will calculate what is Px, Py, Px, Qi, Rz. So if you take Px, if you take Px, so kr power n minus 1 x, that is 1. So kr power n minus 1 into x, here dou by dou x, that is the meaning here. Okay, so if we look at this with respect to x, so what I am getting here is that dou by dou x. So k is a constant here. Dou r by so I have dou by dou x of r power n minus 1 into x. So I apply UV rule here. If we apply UV rule here, k into r power n minus 1, okay, plus n minus 1 into r power n minus 2 dou r by dou x. That is important. Okay, because we are doing with it. So what is dou r by dou x? We have already calculated dou r by dou x here. X by r. It is x by r. So it is x by r here. So k into r power n minus 1 plus n minus 1 into r power n minus 2 x by r. So this is nothing but k into r power n minus 1 plus n minus 1 into r power n minus 2 x. So, so you can see this as, yeah, this is one. And now similarly, so we got px as k into r power n minus 1 plus n minus 1 into r power n minus 2 into x. Okay, there is one more x is missing here, I think. Yeah, here because one x is missing here. X is already there here. X is there already here. So you have x square, x square. Right, good. So this is what we have. So similarly, you can say qi is k into r power n minus 1. Similarly, I mean, because that's a symmetric function, n minus 2 y square, and qz is k into r power n minus 1, n minus 1 r power n minus 2 z square. So if we add all these things, so we have px, that is what we have divergence of, okay, rz. Please remember this is r is equal to k into 3r power n minus 1, okay, uh, plus n minus 1 into r power n minus 2 into x square plus y square plus z square. And we know that x square plus y square plus z square is r square. So this is equal to k into 3r power n minus 1 plus n minus 1 into r power n minus 2 to r square. So this results in k into r power n minus 1 plus n minus 1 r power n. So this is what we are getting here. So for this to be 0, k must be equal to 0. K must be equal to so he is asking for n value. So okay, n you can easily see. When can this be equal to 0? When can this be equal to 0? So you have del this one divergence of a bar is k into 3 power 3 into r power 3 into r power n minus 1 plus n minus 1 into r power n. So for this to be equal to 0, what is n he is asking? So for that to be equal to 0, your n must be equal to. So what are the choices? We'll see what is there. It is simple thing. So can n be equal to, say for example 0? That will see. If your n is 0, you have 3r power minus 1 minus n. No, so 0 is not the choice. So if it is 1, so you have 3. 3 into r power 0 is 1. No, it also not equal to 0. If it is 2, 3r, but on the other hand you have r square, that also not equal to 0, minus 2. So what will be the answer here? Okay, the answer will be, think for no choice here, there is some 27 a. So it says minus 2. Please check once this computation. You are getting r power minus 3 there. Yeah, r power minus 3. Good. So it is minus 2. Good, good, good. So see here. If it is minus 2, see here, r is minus 2 means this becomes minus 3. So this becomes minus 2 minus 1. So minus 3. So this again becomes minus 2. Okay. So this is r power minus 3 is coming. Here minus 3 is coming. So what is that? There is small error. Maybe here 1 minus n may be there. So that may be the choice. Let me check quickly. Let me check quickly. Modulus of a bar into that direction. It is okay. Unit vector along r bar is r bar by modulus of r bar. So kr power n minus 1. Why I took kr power n minus 1? Because it is given as modulus of a bar is kr power n, right? So it is found as kr power n r bar by r, so it is right. So it is kr power n minus 1 into xi bar plus yj bar plus zk bar. So that is also correct. That is also correct. So pi bar, so that's right. So kr power n minus 1 into x I am calculating. So if we take that, k into r power n minus 1 dou x by dou. Okay, just a minute. So here, see what happened is n minus 3 will come. Small error happened here. Right. Now it will be. Okay. Right. Good. Now it will come. So here also n minus 3. Small mistake. Good. Okay. Now here. Right. Z square. Right. Right. R square. So we are getting n minus 1 here. That is the problem. Right. Now we are done. Right. So further simplification yields. Okay, good. Right. Now it is clear. Divergence of A bar is okay. K into 3r power I mean n minus 1 plus 3 into r power n minus 1. Right. So here this is equal to further equal to k into n minus n plus 2 r power n minus 1. So what we have achieved is divergence of A bar is equal to k into n plus 2 into r power n minus 1. Now divergence of A bar is equal to 0 implies n plus 2 must be equal to 0. Okay. So this implies n is equal to minus 2. Okay, that is the answer. Right, good. That is the answer. We go for the next question. Okay. For the spherical surface x square plus y square plus z square is minus 1 is equal to 1, that is the unit outward normal vector at the point 1 by root 2 comma 1 by root 2 comma 0. Okay, what is the surface equation here? So the surface equation is x square plus y square plus z square is equal to 1. So this I can write as f is equal to 1. You can equation that is. So for this one, if we want, this is called level surface. If we want a normal vector here, that is represented by gradient of f. That is represented by grade f. So grad f, that is what is that? F of x, fx I bar plus fy dou f by dou y z bar plus dou f by dou f by dou z k bar represents okay outward normal vector, outward normal, outward normal to the surface f is equal to 1. So what is our f of fx here? Our fx is x square plus y square plus z square. So what is f of x y z, I mean? So here fx is 2x, fy is 2y, fz is 2z. So what is the normal vector here? It is grad f. It is grad f is 2xi bar plus 2yj bar 2zk bar 2zk bar. So now we calculate, this is a new unit normal vector. Unit normal vector means first calculate what is modulus of grad f. So modulus of grad f, that is normal vector. So you can treat this as normal vector. Okay, to that surface. So so this is 4x square plus 4y square plus 4z square. But on the other hand, what is, so this is nothing but, square root is there. Square root is there. So I write here square. I write here square. Okay. So this is therefore grad of whole square, that is norm square, is 4 into x square plus y square plus z square. But we are on the sphere x square plus y square plus z square equal to 1. So 4 into 1, this is 4. So unit norm, the modulus of grad f is, that is normal, is 2, is positive, non-negative number grad f. So unit normal vector now. What is unit normal vector? You have grad f is here. So our okay. Hmm. So our n cap is this is our no n cap unit vector, that is okay, right. So what we are asking for, what we are asked to do. So unit outward normal vector at the point 1 by root 2 1 by root 2 0. So this is unit outward normal vector, and now it is at 1 by root 2 1 by root 2 0. So this n cap at 1 by root 2 1 by root 2 0 is given by 1 x, in place of x you put 1 by root 2 1 by root 2 I bar plus y 1 by root 2 j bar plus 0 into k bar. So this results in the unit vector is now at that point 1 by root, we have 1 by root 2 into I bar plus j. So if you look at this, yeah, A will be the answer. Now see this one. The curl of the gradient of the scalar field defined by, the curl of the gradient of the scalar field is defined by that field. The curl of the gradient of the scalar field, okay, defined by, okay, right. Hmm. So the gradient of the scalar field, okay. So curl of gradient of scalar field is always 0 by 11. You need not do any calculation here. So one need not do any calculation here. So you can straight away say it is 0. Okay. So 30, for 30 the answer is D. For 30 the answer is D. Right. One need not do any computation here for 30. Okay. Then yeah, you take this one. Given vector field is, so here ax, ay, az we been unit vectors along x and y, x, y and z axis respectively. So in place of ax you can take I bar, in place of ay you can take j bar, and in place of az you can take k bar. So now in this problem, in this problem. So what is f bar? Y square x. So f bar is okay y square x I bar minus yz j bar I think I'm taking that as minus because there is a maybe a printing error. So minus x square k bar. I'm taking it as minus sign x square k bar. Right. If I take like that, the line integral need to be evaluated along the segment x-axis from x equal to 1 to z. So what is my r bar? Always I suggest you to go in this way. So what is dr bar dxi bar plus dyj bar dzk bar? Right. So now f bar dot dr bar. Now f bar dot dr bar. So f bar dot dr bar is equal to f bar dot dr bar y square x dx y square x dx minus yz dy minus yz dy minus x square dz minus x square dz. So f bar dot dr bar is this. F bar dot dr bar is this. Right. We are doing integration along the line x is along x-axis from x is equal to 1 to x is equal to 2. So along x-axis from 1 to 2 means you have okay along x-axis. What is happening? Y is equal to 0, z is equal to 0. Of course, and we have one less than or equal to x less than or equal to 2. This is all put together or see the curve need to be evaluated. Need to be line integral need to be evaluated. So along this curve, what is happening? Dy is dz is 0. That is first thing. And yeah, 1 is less than or equal to x less than or equal to 2. Further, there are one more point to be noted. Y is equal to z is equal to 0. This is the thing we need to note. So if we put this data, Here, if we put this data here, y square x dx y square x dx minus yz dy minus yz dy minus x square dz. And you have c here. So when y is 0, z is 0, the this c, this component will become 0. And y is dy is 0, dz is 0. So because y is 0, this is also 0. So the entire integral now becomes 0. So here B is the answer for 31. B is the answer for 31. Yeah, right. B is the answer for 31. B is the answer for 31. So this is also a similar question. I choose same divergence. This is also same question. So for this one, okay, the answer for 41 is 0. We are using divergence theorem. 3.14 into dou by dou x. Divergence of f bar is becoming 0 here. So that is if we use okay. So we'll see this one. The line integral of the function f bar is equal to yz I bar in the counterclockwise direction along the circle x square plus y square is equal to 1 and z is equal to 1. Yeah, this problem we will see. So what is our f bar here? Our f bar here is yz I bar. So what is r bar? Whenever line integral is coming, you can take this always. And the next step is dr bar you need to calculate. That is equal to dx I bar plus dy j bar plus dz k bar. Once that is done, then you simply calculate what is f bar dot dr bar. Only f bar has I bar component. So yz dx is the only thing. The remaining thing is 0. Now see, what is the circuit? What is the curve we have to see? Because we need to evaluate f bar dot dr bar along the curve C. So what is this C is the natural question. You have to see. So your C is a curve. See, your C is like this. You have x square plus y square is equal to 1. On the other hand, z is 1. Right. Z is 1. So here you have because z is 1, because z is 1, and of course you have dx, and now you need to write what is y. See, because you can, if you look at this, I mean the line integral f bar dot dr bar over c. I'm talking. So this is y is I can write from here y is square plus y is square root of 1 minus x square, and your z is and your z is 1. So you have dx. Okay, you have dx. Right. Right. Okay. I'll do one thing. You can say here yz is there. Yeah, that's all. You can integrate this and we can get. So here x is varying from 0 to 2 pi because it's a full circle. It's a full circle. Actually, one can also take a here we can also think like this, that circle equation parametric form is x is equal to cos t, y is equal to sin t. So here dx is minus sin t dt, and your t varies from 0 less than equal to t less than equal to 2 pi. Z is anyway 1. So we better follow this way in order to get the answer. Okay, if you follow this, if you follow this, so you have here yz, dx is there, you have the curve C. Okay, so with this, is equal to, this is equal to integral you have, z is anyway 1, z is anyway 1, please remember that, so dz is 0, z is 1, and your y is sin t, y is sin t, z is anyway 1. and dx is minus sin t dt, and your t varies from 0 to 2 pi. Yes, this is done. So this is equal to integral minus 0 to 2 pi sin square t dt. That's all. So sin square t minus sin square t. Okay, you have cos 2t minus 1. Cos 2t minus 1 by 2. So that's all. Now for cos 2t, you have half here. Cos 2t integral is sin 2t by 2. T is there. Here 0, 2 pi is there. But this vanishes at both 0 and 2 pi. That vanishes at both 0 and 2 pi. So now the answer is, you have, okay, we have minus 2 pi is the answer. Minus 2 pi, and you have 1 by 2 into minus 2 pi. Minus pi will be the answer. So are we getting minus pi? B. 43 is B. Yes, we got minus pi. Okay, so for now, we will close this one. We have done good number of problems today. We have done good number of problems. Almost 14 to 15 problems we have done. On line integrals, divergence, gradient, curl, the ideas of curl, all these we have seen, and we have done some examples from old question papers of the GATE exam. We will continue our discussion in the next class. So we'll continue our discussion in the next class.